Hi everyone, today we're going to learn about arithmetic sequences. We will learn how to find the nth term of an arithmetic sequence. Let's first of all see what is the meaning of arithmetic sequence. When the difference between successive terms of a sequence is always the same number, the sequence is called arithmetic. What is successive terms? Let's say I have a sequence as A1, A2, A3, A4, and so on. So two successive terms are two terms that one comes after the other one. For example, A1 and A2. These are successive terms because A2 comes after A1. A2 and A3. A4 and A3. Because A4 comes after A3. So these are the successive terms here. Now, if the difference between any two successive terms is always the same thing, then this sequence is called arithmetic sequence. Let's look at this example. In this example, let's first of all check the first two successive terms here, 1 and 5. So I subtract 1 from 5. 1 from 5, which will be 5 minus 1, which is equal to 4. So the difference between the first two successive terms is 4. Now let's look at the difference between the second two successive terms. So I do 9 minus 5 is equal to 4 again. So this is also 4. Then 9 and 13. 13 minus 9 is equal to 4. So the difference between any two successive terms is always 4. That means this sequence is an arithmetic sequence. Let's look at the next one. Again, any two successive terms I consider they should have the same difference in order to have an arithmetic sequence. So let's look at the first two ones. I'm going to do 2 minus 7. Notice you always subtract the first one from the second one, like 2 minus 7 or negative 3 minus 2. We're not going to do 7 minus 2. It's going to be 2 minus 7. So 2 minus 7 will be equal to negative 5. So the difference between the first two terms is negative 5. Now, negative 3 minus 2, this will also equal to negative 5. So this is also equal to negative 5. The next one, negative 8 minus 3, minus negative 3. So we are subtracting negative 3 from negative 8. So it will be negative 8 minus negative 3. This will be equal to negative 8. Negative times negative is positive. So it will be negative 8 plus 3, which is equal to negative 5. So again, the difference between these two terms is also negative 5. So this is also an arithmetic sequence. Let's just have a quick check at what happens between the terms when we have arithmetic sequence. In an arithmetic sequence, you consider the difference between terms, and in order to get the next term, you just need to add the difference to the previous one. Like in order to get 5, you just have to add 4 to 1. So 1 plus 4 is 5. To get 9, you just need to add 4 to the 5. So 5 plus 4 is 9. To get the next one, you just need to add 4 to 9. So 9 plus 4 is 13. The next term will be 13 plus 4, which is 17. Then 17 plus 4, which will be 21. And the same way, you can find the next terms. To find the next terms of this sequence, you're going to write 7, then add the difference to the first term. So 7 plus negative 5 will be 7 minus 5. So 7 minus 5 will be 2. Then to get the next term, you're going to do 2 plus negative 5. We know that 2 plus negative 5 is equal to, actually, positive and negative will be negative. So 2 negative 5. 2 minus 5. So it will be 2 minus 5 and it's equal to negative 3. Then negative 3 minus 5 is negative 8. Negative 3 minus 5 is negative 8. To find the next term, we're going to do negative 8 minus 5, which will be negative 13. The next one, negative 13 minus 5, negative 18. So that's how you find the next term of this sequence. So in an arithmetic sequence, you just find the difference between terms and add that to each term to get the next one. Now let's look at this problem over here. Determine if the following sequences are arithmetic sequence. So we want to know if this sequence is arithmetic or not. We know that the rule for arithmetic sequence is that the difference between any two successive terms should be always the same number. So I need to find the difference between these terms. The difference between 4 and 6. 6 minus 4 is 2. So the difference between these two is 2. Difference between 6 and 8. 8 minus 6 is 2. Difference between 10 and 8. 10 minus 8 is 2. So as you notice here, the difference between successive terms is always the same thing. So this is a sequence which is arithmetic. So this is an arithmetic sequence. Let's look at the next one. Difference between these two terms. 3 minus 1 is 2. So the difference between these two is 2. The next one. 7 minus 3 is equal to 4. So the difference between these two is 4. And 11 minus 7 is equal to 4. So as you see, the difference between successive terms is not always the same. Once here is 2, the other 2 times is 4. So this is not always the same thing. So this is not an arithmetic sequence. Let's check the next one. Difference between 2 and 4. 4 minus 2 is 2. So this is 2. Difference between these two. 8 minus 4 is 4. Difference between 16 and 8 is 8. So as you see, the difference between the terms is always something different. It's not always the same thing. So again, this one is not an arithmetic sequence. Now, here we want to find the general rule for the end term of an arithmetic sequence. I will explain here how to find the general rule of the end term. You don't have to memorize this process. I'm just going to explain this to you to see how we get this. So see what happens that I can write this as my general rule of the arithmetic sequence. So in an arithmetic sequence, the first term is A1 and the difference between terms is D. So to find the next term, I'm going to take the previous term and add D to that one. So it will be A1 plus D. To get A3, again I need to get the previous term, which was A2, and add the difference to that. So it will be A2 plus D. Well, what was A2? We just got that A2 was A1 plus D. So I'm going to replace that here. So instead of A2, I'm going to write A1 plus D. And we also had another D here. I'm going to write it here. So it will be A1 plus 2D. So A3 is equal to A1 plus 2D. To find A4, again, I'm going to go back to A3. a3 and I add a d to that one. It will be a3 plus d. What was AD? We just got that AD was A1 plus 2D. So I replace this for A3. So now I have A1 plus 3D. I can add the D's together. It will be 3D. So you notice that for A3, I have A1 plus 2D. For A4, I have A1 plus 3D. So if I want to find A5, obviously I'm going to do A1 plus 4D this time. Or if I want to find A6, I need to find A1 plus 5D. So I can make a general rule for this. To find the nth term of arithmetic sequence, I take an, write an equal to A1 plus n minus 1D. Because here, for A6, I found 5D. So I'm going to write n minus 1D. So this is the general rule for n term of an arithmetic sequence. Let's make some notations here. So an is the nth term. A1 is the first term. N is the number of the term, or you can just write term number. And D is the difference between terms. You can call that as common difference. So now let's look at this example. In this example, we want to find the formula for the nth term of each of the following arithmetic sequences and then apply it for the specific term which is given here. Okay, so here I have A1 equal to 3 and D is equal to 2. The first thing we want to find is an. To find an, we know that the general rule is this. A1 plus n minus 1 times D. A1 is given here is 3, so I'm going to replace that here. Plus n minus 1 times D, which is equal to 2. So this is the general rule for nth term, but I can simplify this. So I can distribute this 2 here. It will be 3 plus 2n minus 2. And then combine the like term, like 3 and negative 2 will be equal to 1. So I can write 2n plus 1 as the general rule for my nth term. So I can write an is equal to 2n plus 1. Now I want to find a5. So to find a5, all I need to do is to replace 5 for n. So in the equation that I have here, into the formula that I have here, I'm just going to write 2 times 5 plus 1. 2 times 5 is 10 plus 1 is 11. So this is my fifth term of this sequence. Now let's work on the next one over here. This time I have A2 equal to 12, D equal to 7, and I need to find A10. First of all, we need to find an. To find an, we need A1 and n minus 1 times D. But we don't have A1 here yet. Let's see how we can find A1. Using A2, I know that A2 is A1 plus 2 minus 1, which is 1D. So it's 2 minus 1D 2 minus 1 is 1, so it's basically A1 plus D. Okay. And that's equal to 12 because we said A2 is 12. And we also know that D is 7. So A1 plus 7 is equal to 12. So from here, if I subtract 7 from both sides, A1 will be equal to 12 minus 7, which is 5. So we found A1 here. Now I can easily write the rule for AN. Let me make some space here for myself. Okay. So for AN, I'm going to write A1, which is 5, plus N minus 1 times D, which is 7. Now I distribute this 7 here to simplify my expression. So this will be 5 plus 7n minus 7. So if I combine 5 and negative 7 will be negative 2. So the general rule an will be 7n minus 2. So this is my general rule of the nth term. Now to find an, I'm just going to write 7 times. Instead of n, I'm going to replace 10 here. So it will be 7 times 10 minus 2. 70 minus 2 is 68. So this is my 10th term here. Now let's work on this example. In this example, we have A8 and A12. We want to find an. So to find an, we know that we need to know A1 and the value of D, the common difference between the terms. All I have here is A8 and A12. I need to find A1 and D from these two. So let's write the rule for A8. A8 is equal to A1 based on the formula that we have here. A1 plus n minus 1 times D. But what is n? It's 8. So I'm going to replace 8 for n. Then what is 8 minus 1 is equal to 7. So I'm going to write A8 is equal to A1 plus 7 times D. Now what is A12? Is A1 plus 12 minus 1 times D. So A12 is equal to A1 plus 11D. On the other hand, we know that A8 was equal to 26 and A12 was equal to 38. Now I have a system of equation here. A1 plus 7D equal to 26. I'm going to highlight that. One equation here and one here. I'm going to use system of equation to solve this. How do I solve that? I can multiply the bottom one by negative 1. So I'm going to have A1 plus 7D equal to 26 and negative A1 minus 11D equal to negative 36. Then I add these two. So A1 and negative A1 will cancel each other, and here I will have 7D minus 11D will be equal to negative 4D. Then 26 minus 36. Um, I'm sorry, this is 38. 26 minus 38 will be negative 12. And from here, if you divide both sides by negative 4, d will be equal to 3. So from here, we found the value of d. Now I'm going to replace d to one of these equations and find the value of a. So in the first one, which I had a1 plus 7d equal to 26, I replaced d for here. The 3 will go here, so it will be a1 plus 7 times 3 equal to 26. a1 plus 21 equal to 26. Then you subtract 21 from both sides. So a1 will be equal to 5. Okay, now we have d and a1. I can easily write the general formula for nth term. an will be equal to a1, which is 5, plus n minus 1 times d, which is 3. So this is the general rule for the nth term. Okay, now let's work on this problem. In this one, a7 and a13 is given. So we're going to use the same rule. an equal to a1 plus n minus 1 times d. So a7 is equal to a1 plus 7 minus 1, which is 6d. It's equal to 15. The next one, a13, is equal to a1 plus 12d, because 13 minus 1 is 12, is equal to 18. Now I have another system of equation, these two. I'm going to solve it. Let's multiply this one by negative 1. So we will have a1 plus 6d equal to 15, and then negative a1 minus 12d equal to negative 18. So if I add them, these two cancel each other, and it will be negative 6d is equal to negative 3. Now I divide both sides by negative 3, and d will be equal to, divide both sides by negative 6, d will be 1 over 3. So we found d value. Now I'm going to replace this d into one of these formulas and find a1. So here a1 plus 6 times 1 over 3. I replace 1 over 3 in this formula, is equal to 15. a1 plus 6 times 1 over 3 will be simplified as this. 3 by 3 is 1, 6 by 3 is 2. So it will be just 2. a1 plus 2 is 15, and subtract 2 from both sides. From here, a1 will be equal to 13. Now we can write the formula for an. a1 was 13. 13 plus n minus 1 times d, which is 1 over 3. So this will be the general rule. We can also simplify this more. it will be 13 plus n over 3 minus 1 over 3. 13 and negative 1 over 3 will be 39 minus 1, which will be 38 over 3. So it will be equal to 38 over 3 plus n over 3. This will be the general rule for this sequence. Now in this example, we want to find the 41st term of the arithmetic sequence, which is given as 2, 6, 10, 14, and 18. So let's have a closer look at this sequence. The first term is 2. The first term is given as 2. This is an arithmetic sequence. That means the difference between any two successive terms is going to be the same. 6 minus 2 is 4. 10 minus 6 is 4. 14 minus 10, 4. 18 minus 14 is 4. So the value of D, or the common difference, is equal to 4. Now, I can write the general rule for nth term. An will be equal to A1, which is 2, plus n minus 1 times D, which is 4. Notice I'm using this formula that I gave you in the previous page. An equal to A1 plus n minus 1 times D. That's the formula that I'm using here. Okay, so now I can simplify this. Distribute the 4 here. It will be 2 plus 4n minus 4. So 2 and negative 4 will be negative 2. So this will be 4n minus 2. Now, in order to find A41, I just need to replace 41 for n. So it will be 4 times 41 minus 41 minus 2. This will be equal to 162. Now let's find the formula of the nth term of this sequence. 2, 5, 8, 11, and so on. So we need the first term, which is given here as 2. Also, we need to find the common difference, D. So let's subtract each term from the previous one. 5 minus 2 is 3. 8 minus 5 is 3. 11 minus 8 is 3. So the common difference is 3. Now, to find the nth term, An is equal to A1 plus n minus 1 times D. A1 is 2 and n minus 1 times 3. So this is the general rule. I can simplify this more by distributing this 3. It will be 2 plus 3n minus 3. 2 and negative 3 will be negative 1, so it's 3n minus 1. So the general rule will be An equal to 3n minus 1. Now let's work on this problem. Edwin is getting better at math. On his first quiz, he scored 57 points. Then he scored 61 and 65 on his next two quizzes. If his scores continue to increase at the same rate, what will be the score on his ninth quiz? Show all your work. Okay, so here the first quiz was 57. The second quiz is 61. Third one is 65. And he's going to continue score on his quizzes the same way. That means If the difference between these two, 61 and 51, the difference is 4. And difference between 65 and 61 is also 4. So if the difference between these two successive terms is 4, the difference between the next two successive terms is also going to be 4. So we're going to have an arithmetic sequence here. In this arithmetic sequence, A1 is 57 and the common difference is equal to 4. Now, if I want to find the ninth quiz of this student, let's first of all find the explicit formula for the sequence and find the general rule for AN. So AN will be equal to A1 plus n minus 1 times D. AN will be equal to A1, which is 57, plus n minus 1 times D, which is 4. So that's the general rule. If I distribute these, it will be 57 plus 4n minus 4, which will be equal to 4n plus 53. So this is the general rule for AN. Now, in order to find the ninth quiz, I'm just going to replace n equal to 9 into this formula. So AN, or A9 actually, will be equal to 4 times 9 plus 53, which will be equal to 89. So that's the quiz number for the 9th time. In order to write the final answer as a sentence, we can write Edwin will get a grade of 89 in his 9th quiz. So this was today's lesson. Hopefully you learned and it was helpful for you. Start working on your homework to learn more. Have a great day.